Okay, we're going to talk about making sense of unknowns on both sides of the equation. So first, let's go back to our visual representation. So if we have a balance scale and we have a bag on this side and a bag on this side. Let's say we have two bags on this side and we have I don't know, 5 coins over here. Okay, so how much is in each bag? Well, before we were used to just taking off an equal number of things from both sides, but we can take this whole bag because this bag is equal to this bag, right? So if I take that bag off and that bag off, then I'd be left with one bag. Man, my bags look ugly. Let's make it look pretty. Okay. So that bag that's left over is equal to 5. So that means the originals were equal to 5. So you could see that if this was 5 and 5, there's 10 there, and then 5 and 5, there'd be 10 there. So 10 is equal to 10. Okay, so that's the possibility where, and we'll just call the bag x, so x is equal to 5. Now, what if we had something weird like this, where it was two bags and two bags? Okay, and then so I'll take a bag off of this side and take a bag off of this side. So if that bag equals that bag, should I take that bag off and that bag off? So then it would still be equal, but I have 0 equals 0, which doesn't really tell us anything. Well, that wouldn't really tell us anything, right? So what are some possibilities that would make this true? And if you start to think about it, you could realize, oh, okay, I could take the bag off of each side, so something is equal to something else, the same thing, right? And there's the same number in here as there is in here. Well, this is a possibility where x could be any number, right? It could have 5, and then 5 would equal 5, or I could have 15, and 15 would equal 15, or maybe it's 2.7, right, and 2.7. So really any real value is a possibility. So this is all real numbers. And usually they would put it in some sort of set notation, like use these curly braces, and x would be an element of the reals. So that's how you'd say all real solutions. But what's something else that could happen? What if we had two bags again, and let's say two bags and 5 coins. All right. So there, let's say, okay, I take two bags off, and I take two bags off, and then I have 0 equals 5. But 0 does not equal 5, so it should have tipped, right? It should have tipped when I take those off, but we know from our properties of equality that if you remove something from one side and remove something from this side, they should still be equal. So this is not really a possible situation. So this is something where I would say there is no solution. And actually, whatever number you put in there, so say I put 5 into each bag, then there'd be 5, 10, and 15 on this side, and 5 and 10, there'd be 10 and 15, so 10 does not equal 15. And you would find out that whatever number that I put in there, it would always be two numbers that are not equal. So there are three possibilities. You could have one solution. You could have an infinite number of solutions. Or you could have no solution. And this is the case when you have x's on both sides of the equation. Okay, so let's go ahead and do some problems that have x's on both sides of the equation. Now looking at this, I know the x's aren't going to cancel out, so we are going to have one solution. If they were going to cancel out, it would be one of the other two types. It could be an infinite number of solutions or no solution. But in this case, I know there's going to be one. So what I want to do is what I want to shoot for is to get it like this, right? 1x by itself, and then the number, right? So this is the goal. This is our goal, right? So if we can get to that, we're okay. And this is just 1x with nothing added to it, right? So plus 0. And so if I want to do that, I'll bring all the x's to this side, all the numbers to that side, and I want to only have one of them. So in this case, it's nice because if I take away an x, so I subtract an x from that side, it makes it 0. I'm going to take away an x. I have to do it to both sides. That's the property of equality. So I get 2x, take away an x would just be 1x, right? And that's what I want is 1x. While I'm at it, let's move that 3 out to the other side. So I'm going to add 3 to undo the subtracting 3. And so this would be x, take away x is 0, so it goes away. 5 plus 3 is 8. So you get 1x is equal to 8, or 1 times any number is that number, so we just say x is equal to 8. And by the way, this was plus 0. So that's what I want to get to is 1x plus 0, which is just x. Alright, so the value that makes this original statement true would be 8. So let's just check it. So 2 times 8 minus 3, does it equal 8 plus 5? So 2 times 8 is 16, minus 3 would be 13, and 8 plus 5 is also 13. So this statement is true. So it worked out. So let's do an example where it would have an infinite number of solutions. So maybe it's 2x minus 5 equals 2x plus 10 minus 15, right? So if I subtract 2x from both sides, the x's go away, right? This is 0, and this is 0, so I have no more x's in the problem, and this would be negative 5 equals 15, or 10 minus 15 would be negative 5. So this is a always true, right, statement. Whatever x is. Whatever your x. Right, so this, any value of x that I plug in would make the statement true, so x is an element of the reals. And you can check it. Let's just try any old real number. How about square root of 2, right? So is 2 times the square root of 2 minus 5 equal to 2 times the square root of 2 minus 5? Yeah, that makes sense. So the last type would be something that is never true. So you can recognize those. So how about 3x minus 4 equals 3x plus 2? So I know that this is never going to be true because when I cancel out my 3x's, all the x's go away. So this is 0 x's and 0 x's. So I get negative 4 is equal to 2, which is not true, right? So this is not true. So x is no solution. And there's no real way to check it. You could plug in a value, right? 3 times, I don't know, let's say check 2 equals 3 times 2 plus 2. And you can see that whatever number you put in, it's never going to equal out, because if I have 6 on this side and 6 on this side, if I just take out the 6's, I have negative 4 equals 2. And let's say I take out the 2 too, so I subtract 2 from both sides, so I get negative 6 equals 0. Well, negative 6 is not equal to 0, so this is never going to be a solution. Okay, so that's just an example using the variables and numerical solutions.